Germans never expected America's P-51 Mustangs would dominate the skies and break the Luftwaffe. December 1943, somewhere over Berlin. Hermann Göring once boasted that no enemy bomber would ever fly over the Reich. For years, his words seemed prophetic. German fighters ruled European skies, shooting down Allied bombers by the hundreds. American flying fortresses limped home with gaping holes if they made it home at all. Then something impossible happened. Silver fighters with distinctive checkered noses appeared over Berlin itself, escorting bombers all the way to the heart of Germany. The Luftwaffe scrambled to intercept, but these weren't the short-range fighters they knew. These Mustangs could fly further than any fighter in history, turning and fighting with deadly precision. German aces who had terrorized Allied formations suddenly found themselves outmatched, outgunned, and running out of fuel. How did one aircraft change the entire course of the air war? What made the Mustang so revolutionary that it broke the back of Hitler's Air Force? And why were the Germans completely unprepared for what was coming? Before we get into the story, comment below where in the world you are watching from today. The morning of November 8, 1943, dawns gray and bitter across Royal Air Force Debden in Essex, England. Frost clings to aircraft wings like crystalline armor, each ice shard catching weak sunlight, filtering through English mist. Mechanics curse as they wrestle with frozen bolts and stiff control cables, their breath steaming in air cold enough to crack exposed skin. The metallic cough of a Packard-built Merlin engine cuts through pre-dawn silence, followed by the full-throated roar as 1,200 horsepower springs to life. Captain Don Blakesley of the 4th Fighter Group emerges from the operations hut, leather jacket zipped against November wind. At 28 years old, Blakesley commands respect earned through 2 years of combat over European skies. His weathered face tells stories of dogfights over France and desperate scrambles to protect crippled bombers limping home across the English Channel. Today feels different. The P-51 Mustang warming behind him represents something unprecedented in aerial warfare. For months, American bomber crews have faced a grim reality. Flying fortresses and liberators take catastrophic losses on deep raids into Germany. Without long-range fighter escort, bombers rely solely on defensive firepower against swarms of Luftwaffe interceptors. Mission planners watch loss rates climb toward 30% on strikes against Berlin, Hamburg, and the Ruhr Valley. Entire squadrons disappear in single missions, young men vanishing into European skies with their dreams of returning home. Republic P-47 Thunderbolts and Lockheed P-38 Lightnings provide excellent service, but neither possesses sufficient range to escort bombers to distant targets. Thunderbolts carry enough fuel for missions extending roughly 600 kilometers from base. P-38 stretch slightly further but struggle with reliability issues in European weather conditions. Both fighters must turn back long before bombers reach primary targets deep in German territory. American commanders search desperately for solutions. Boeing B-17 Flying Fortresses and consolidated B-24 Liberators represent massive investments in men, materials, and strategic capability. Each bomber costs roughly $238,000 to build and requires months to train 10-man crews. Losing aircraft faster than factories produce them guarantees strategic failure and prolonged war. Blakesley climbs into his Mustang cockpit, settling into worn leather seat cushions that smell of oil, metal, and previous missions. The aircraft around him embodies American engineering evolution. Originally designed for Britain's Royal Air Force, early Mustangs flew reconnaissance missions with modest performance. Everything changed when North American aviation engineers mated British Rolls-Royce Merlin engines with Mustang airframes. The combination creates something extraordinary. As Blakesley runs through pre-flight checks, he knows today's mission will test new possibilities. His squadron will escort bombers further into German territory than any previous fighter mission. Drop tanks extend operational range to unprecedented distances. For the first time, American fighters might accompany bombers all the way to targets and back, transforming air warfare mathematics. The Merlin engine settles into steady rhythm. pistons firing in precise sequence that vibrates through aluminum fuselage into Blakesley's bones. Ground crews pull wheel chocks and signal thumbs up. Radio crackles with tower clearance. Mustangs taxi toward runway, frost melting from wings as engines warm metal structures. Blakesley advances throttle and feels acceleration press him into seat cushions. The runway blurs beneath landing gear before Mustang lifts gracefully into English sky. Behind him, squadron mates follow in fighting formation, silver aircraft climbing toward rendezvous with bomber streams already forming over East Anglia. Each pilot understands they carry more than ammunition and fuel. They transport hope that American air power can finally reach German industrial heart without prohibitive losses. 500 kilometers west of Debden, sparks cascade like metal rain from rivet guns inside Ford Motor Company's Willow Run plant near Detroit, Michigan. The cavernous factory stretches across 167 acres under a single roof, creating the largest manufacturing facility on Earth. Rosie Will Monroe adjusts her polka-dot headscarf and leans into thunderous noise that would deafen anyone without proper ear protection. Her hands, blackened with oil and grease, guide aluminum sheets into position with practiced precision. Monroe represents thousands of American women who flooded defense plants after Pearl Harbor. Former waitresses, teachers, and housewives now operate drill presses, bucking bars, and hydraulic forming machines with skill matching any peacetime craftsman. Their work creates weapons that will determine war's outcome across oceans they may never see. Willow Run produces consolidated B-24 Liberator bombers using revolutionary assembly line methods adapted from automobile manufacturing. Henry Ford's engineers designed production systems enabling unprecedented output rates. At peak efficiency, completed bombers roll from factory doors every 63 minutes, 24 hours daily. The facility employs over 42,000 workers across 3 shifts, transforming raw aluminum into flying weapons faster than military. Planners once thought possible. Each bomber requires approximately 450,000 individual parts, assembled with microscopic precision. Wings span 33 meters and contain fuel tanks holding over 11,000 liters of high-octane gasoline. Wright R-1830 twin-wasp engines develop 1,200 horsepower each, driving 3-bladed propellers through gear reduction systems that translate engine rotation into forward thrust. Monroe's rivet gun pounds aluminum sheets together with pneumatic force, creating joints stronger than welded connections. Every rivet must meet exacting military specifications for strength, durability, and weight. Faulty construction means crew deaths over enemy territory and mission failures that prolong war. Her concentrated attention spans 12-hour shifts with minimal breaks, sustained by knowledge that each bomber carries 10 American airmen into combat. Beyond Willow Run's assembly lines, North American aviation facilities in Inglewood, California, and Dallas, Texas, mass-produce P-51 Mustang fighters with equal intensity. These factories operate continuously, transforming blueprints into aircraft that will escort Monroe's bombers through European skies. Engineering teams work around the clock, refining production techniques and implementing improvements discovered through combat experience. The scale defies comprehension. American aircraft production for 1943 exceeds 47,000 military planes, including fighters, bombers, transports, and trainers. Germany, despite controlling much of Europe's industrial capacity, produces fewer than 25,000 aircraft during the same period. Soviet Union contributes additional aircraft to Allied totals, while British factories focus on specialized designs and components. American advantage extends beyond raw numbers into strategic depth. Factories operate thousands of kilometers from enemy bombers, protected by geography impossible for Axis forces to overcome. Raw materials flow from secure sources across North American continent. Skilled workers receive steady wages and adequate nutrition, maintaining productivity levels that fascinate industrial experts worldwide. Monroe pauses her rivet gun as another completed bomber section moves down assembly line. The aluminum skin gleams under factory lighting, reflecting countless hours of American labor transformed into instrument of victory. She cannot see final destinations for her work, but each rivet drives another nail into Axis coffin. Her factory represents democracy's industrial heart beating steadily while enemy production facilities crumble under bombing attacks. As her shift continues, Monroe knows that somewhere over England, pilots prepare for missions that will test her craftsmanship against enemy fire. The bombers she builds must survive flak, fighters, and weather to deliver explosive cargo that shortens war and saves Allied lives. Her rivets hold together more than aluminum sheets. They bind American determination into weapons that democracy wields against tyranny. The assembly line never stops. Day and night, Willow Run transforms raw materials into flying fortresses that carry freedom's message across hostile skies. 2,000 kilometers southeast of Willow Run, beneath ornate chandeliers in Berlin's Reich Air Ministry, Reichsmarschall Hermann Göring examines Luftwaffe operational reports through clouds of expensive cigar smoke. The corpulent leader of German air forces radiates confidence despite increasingly troubling statistics emerging from Western Front operations. His bloated fingers trace loss columns showing steady attrition among experienced fighter pilots. Göring's reputation rests upon early war successes when Luftwaffe dominated European skies with tactical superiority and aggressive doctrine. Messerschmitt Bf 109 fighters swept aside Polish, French, and British opposition during 1939 and 1940 campaigns. Junkers Ju-88 bombers terrorized London during the Blitz, while Henkel He-111s reduced Guernica, Rotterdam, and Warsaw to smoking rubble. Those victories established Göring's authority and reinforced his famous boast: no enemy bomber will fly over the Reich territory. Through 1942, Göring's prediction held largely true. Allied bombing attempts against German targets resulted in heavy losses and minimal damage. Royal Air Force night raids caused more psychological than strategic impact, while American daylight missions barely scratched industrial production. German fighters commanded respect throughout occupied Europe, shooting down Allied aircraft faster than replacement rates could match losses. Recent reports suggest troubling trends. American bomber formations grow larger and better organized. Their defensive firepower increases through improved tactics and concentrated formations. Most concerning, intelligence indicates new long-range fighter development in American factories. Göring dismisses such warnings as enemy propaganda designed to undermine German morale. Luftwaffe technical advantages remain substantial. Messerschmitt Bf 109 Gustav variants match or exceed Allied fighter performance in most categories. Focke-Wulf FW-190 radial engine fighters dominate low-altitude combat with superior roll rates and firepower. German pilots receive extensive training in specialized schools that produce skilled aviators capable of aerial combat excellence. However, cracks appear in Luftwaffe foundation. Fuel allocation for training programs shrinks monthly as synthetic petroleum production struggles to meet military demands. Pilot replacement rates lag behind combat losses, forcing experienced aviators to fly additional missions without adequate rest. Aircraft production, while impressive, cannot match American output levels that intelligence reports describe as impossible. Göring reviews pilot training statistics with growing concern. In 1940, Luftwaffe pilots received over 240 hours of flight instruction before operational assignment. Current training programs provide fewer than 150 hours due to fuel shortages and instructor casualties. New pilots reach combat squadrons with inadequate preparation, resulting in higher loss rates that accelerate the downward spiral. Strategic materials present additional problems. Aluminum supplies depend on imports from countries increasingly threatened by Allied advances. High-octane aviation fuel requires complex refining processes, vulnerable to bombing attacks. Specialized alloys for engine components rely on sources beyond German control. Each shortage creates bottlenecks that reduce aircraft availability and combat effectiveness. Despite mounting evidence, Göring maintains public optimism and private denial. His political position depends upon Luftwaffe success, making honest assessment potentially career-ending. Adolf Hitler expects confident reports that reinforce his belief in ultimate German victory. Admitting systemic problems invites scrutiny of Göring's leadership and opens opportunities for rivals seeking advancement. The Reich Air Ministry's ornate chambers insulate Göring from battlefield realities experienced by combat pilots. Reports filter through multiple bureaucratic layers, sanitizing bad news and emphasizing positive developments. Staff officers present statistics supporting predetermined conclusions rather than objective analysis that might contradict official optimism. Göring concludes his briefing with characteristic bluster, dismissing concerns about American production capabilities and long-range fighter development. He waves away warnings about fuel shortages and pilot training deficiencies. His confidence radiates through smoke-filled chambers, while somewhere beyond Germany's borders, American factories work around the clock to prove his arrogance fatally misplaced. At Packard Motor Car Company's sprawling plant in Detroit, Michigan, a different kind of engine roars to life, shaking factory windows and rattling tools hanging from overhead racks. The Packard-built Merlin V12 engine develops 1,266 horsepower at 3,000 revolutions per minute, creating more power than a dozen automobile engines combined. Engineers and test technicians cheer as dynamometer. Readings confirm another successful adaptation of British Rolls-Royce design for American mass production. The Merlin engine represents technological marriage between British innovation and American manufacturing capability. Rolls-Royce originally developed the engine for Royal Air Force Supermarine Spitfire fighters, creating sophisticated power plant with superb high-altitude performance and exceptional reliability. However, British production capacity cannot meet escalating wartime demands for fighters, bombers, and other military aircraft. Packard engineers spent months studying Rolls-Royce blueprints, translating British measurements and specifications into American manufacturing standards. Imperial measurements required conversion to American fractional inch systems. Specialized alloys needed substitution with equivalent materials available from North American suppliers. Production techniques demanded adaptation to Packard's assembly line methods developed through decades of automobile manufacturing experience. The adaptation process revealed fascinating cultural differences between British and American engineering approaches. British designers emphasized handcrafted precision and individual component fitting by skilled mechanics. American manufacturers preferred standardized parts that interchange without modification, enabling rapid assembly by workers with minimal specialized training. Packard engineers successfully merged both philosophies, creating engines meeting Rolls-Royce performance standards while achieving unprecedented production rates. Installation in North American P-51. Mustang airframes transforms modest performers into exceptional fighters. Early Mustangs equipped with Allison V1710 engines showed promise at low altitudes, but suffered performance degradation above 4,500 meters. The Merlin's two-stage supercharger maintains power output at altitudes where combat frequently occurs, giving Mustangs decisive advantages over German fighters optimized for different operating conditions. Range becomes the Mustang's revolutionary characteristic. Internal fuel capacity of 732 liters extends to over 1,100 liters with external drop tanks. Combined with Merlin efficiency at cruising power settings, Mustangs achieve operational range exceeding 2,600 kilometers. For the first time in aviation history, single-engine fighters can escort bombers from England to Berlin and return with fuel reserves for combat. Test pilot results exceed optimistic projections. Maximum speed reaches 712 kilometers per hour at 7,600 meters altitude. Service ceiling extends above 12,700 meters. Rate of climb surpasses 300 meters per minute, enabling rapid altitude advantages during combat engagements. Range and endurance figures verify escort capability to any target within bomber reach. Performance statistics tell only part of Mustang's story. Pilot reports emphasize handling characteristics that inspire confidence during demanding combat situations. Controls remain responsive at high speeds where other fighters become difficult to manage. Visibility from the cockpit enables pilots to spot threats and opportunities with clear fields of view. Armament of 650 caliber machine guns provides concentrated firepower capable of destroying enemy aircraft with short bursts production. Schedules accelerate throughout 1943 as military commanders recognize Mustang potential. North American aviation facilities in Inglewood, California and Dallas, Texas implement assembly line techniques perfected for other aircraft types. Component suppliers across American industrial base gear up for unprecedented production volumes. Packard increases Merlin engine output to meet escalating demands from multiple aircraft programs. By late 1943, over 400 Mustangs per month roll from assembly lines, representing industrial achievement that German planners consider impossible. Each aircraft embodies thousands of hours of American labor, sophisticated engineering, and strategic materials transformed into instruments of aerial warfare. The combination of British design excellence and American production capability creates weapons that will reshape European skies. Engineers, monitoring Merlin dyno tests, understand they witness more than engine development. They observe democracy's industrial heart beating with power that will carry freedom across hostile skies to Hitler's doorstep. December 13, 1943. 30,000 feet above Brandenburg, Germany, Captain Don Blakesley leads his P-51 Mustang squadron through crystalline air so cold that exhaled breath would freeze instantly. Below stretches German countryside under winter snow, while ahead, black dots resolve into Boeing B-17 flying fortresses, maintaining disciplined formation despite flak bursts blooming around their aluminum fuselages. For the first time in aviation history, American fighters accompany bombers all the way to Berlin and prepare to escort them. Home Blakesley's radio crackles with bomber, crew voices expressing amazement at seeing friendly fighters so deep over enemy territory. Previous missions forced bombers to continue alone after escort fighters reached maximum range and turned back toward England. Luftwaffe pilots learned to time their attacks for moments when bombers flew defenseless, concentrating overwhelming force against formations that could only rely on defensive firepower. Today changes everything. Mustangs carry enough fuel to match bomber range while maintaining reserves for extended combat. External drop tanks extend operational radius beyond previous fighter capabilities, enabling escort coverage throughout entire mission profiles. When German interceptors appear, Mustangs can engage without worrying about fuel limitations that previously forced early withdrawal. Contrails stretch across winter sky like chalk marks on blue blackboard, marking passage of largest air armada ever assembled. Over 700 bombers participate in today's mission, protected by nearly 400 fighters, including Blakesley's Mustangs. The formation extends across dozens of kilometers, representing industrial might that democracy marshals against totalitarian opposition. German Messerschmitt Bf-109 and Focke-Wulf FW-190 fighters climb to intercept, their pilots shocked to encounter opposition at altitudes and distances where bombers previously flew unescorted. Luftwaffe tactics assumed fighter escort would abandon bombers long before reaching primary targets. Finding Mustangs over Berlin fundamentally alters air warfare equations and forces German commanders to reassess strategic assumptions. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Blakesley spots enemy fighters climbing from below and calls attack positions to his squadron. Mustangs peel away from bomber escort formation, diving toward German interceptors with altitude and speed advantages. The P-51's superior range means pilots can engage aggressively, without conserving fuel for return flights that stretch fighter capabilities beyond safe margins. Combat develops rapidly, at speeds approaching 800 kilometers per hour. Blakesley's Mustang closes on a Messerschmitt Bf-109, attempting to penetrate bomber formation from below. His 650 caliber machine guns concentrate firepower that German pilots learn to respect and fear. Tracer rounds streak through winter air, marking paths between hunters and hunted in deadly aerial ballet. The Messerschmitt pilot, realizing his tactical position has deteriorated, attempts to dive away from combat. Mustang performance advantages become apparent as Blakesley maintains pursuit through maneuvers that would have allowed earlier German fighters to escape. Superior high-altitude power and excellent diving characteristics enable Mustangs to press attacks that previously ended when escort fighters reached operational limits. American bomber crews watch friendly. Fighters engage enemy interceptors with enthusiasm impossible during previous unescorted missions. Flying Fortress gunners maintain disciplined fire patterns, while Mustangs clear threats from bomber formations. For the first time, bombers reach primary targets with minimal losses to fighter attacks that previously decimated formations attempting daylight raids over defended territory. Statistical evidence accumulates with each mission. Bomber loss rates drop dramatically when Mustang escorts provide continuous coverage throughout mission profiles. German fighter pilots, accustomed to attacking defenseless formations, struggle to adapt tactics for engaging protected bomber streams. Luftwaffe losses mount as experienced pilots fall victim to American fighters appearing at unexpected locations and times. Intelligence reports confirm German confusion over American fighter capabilities. Luftwaffe commanders cannot understand how single-engine fighters achieve range performance that exceeds their own estimates of technical possibilities. Some German reports describe American twin-engine fighters refusing to believe single-engine aircraft can fly such distances while maintaining combat effectiveness. Blakesley returns his attention to bomber formation, satisfied that immediate threats have been neutralized. His squadron rejoins escort positions as flying fortresses begin bomb runs over primary targets. Below, German industrial facilities prepare for explosive cargo that American democracy delivers to fascism's doorstep under protection of superior fighter aircraft. Hans Ulrich. Rudel stamps through ankle-deep snow across the frozen airfield at Gars, Germany, his breath-forming ice crystals that cling to wool scarf wrapped around his neck. Empty fuel drums stand like tombstones beside aircraft hangars, their hollow metallic echoes mocking the legendary Stuka pilot as he searches for enough high-octane gasoline to fill his Junkers Ju-87 for another mission. The fuel shortage that began as minor inconvenience now threatens to ground the Luftwaffe entirely. Rudel has flown over 2,400 combat sorties, destroying over 500 enemy tanks and countless other targets across eastern and western fronts. His Knight's Cross with golden oak leaves, swords, and diamonds represents the highest military decoration Nazi Germany awards. Yet even Rudel cannot conjure fuel from empty barrels or transform inexperienced pilots into combat veterans capable of matching American fighter opposition. The contrast with early war. Abundance shocks pilots who remember 1940 when aviation gasoline flowed freely and training programs produced skilled aviators through comprehensive instruction. Luftwaffe flight schools once provided over 240 hours of preparation before operational assignment. Current programs struggle to deliver 50 hours due to fuel rationing and instructor casualties that accelerate dangerous cycle of inadequate preparation. Young replacement pilots arrive at combat squadrons with flight time barely adequate for basic aircraft operation, let alone aerial combat survival. Many crash during their first operational missions, victims of insufficient training rather than enemy action. Others survive initial encounters only to fall during subsequent sorties when experienced opponents exploit fundamental tactical deficiencies. Rudel examines his aircraft with practiced eye, noting maintenance issues that reflect broader Luftwaffe deterioration. Spare parts arrive sporadically, forcing mechanics to cannibalize damaged aircraft for components needed to maintain operational machines. Engine overhauls extend beyond recommended intervals as replacement power plants remain unavailable. Even ammunition rationing limits training opportunities that might help inexperienced pilots develop combat skills. Synthetic. Fuel production cannot compensate for petroleum shortages that worsen monthly as Allied Bombing attacks target refineries and chemical plants. German industry requires enormous quantities of coal to produce synthetic gasoline through complex chemical processes vulnerable to strategic disruption. Each facility destroyed or damaged reduces fuel availability for military operations, while civilian transportation suffers corresponding restrictions. Romanian oil fields at Ploiești, crucial for German fuel supplies, face continuous Allied bombing missions that gradually reduce production capacity. American heavy bombers, now protected by long-range fighters, strike petroleum targets with increasing frequency and accuracy. German defenses cannot prevent accumulating damage that threatens military operations across all fronts. Weather compounds operational difficulties as winter conditions demand additional fuel for engine warm-up, extended ground operations, and emergency reserves. Aircraft require longer takeoff rolls on snow-covered runways, consuming extra gasoline while increasing accident risks. Heating systems for crew compartments drain electrical power and add weight that reduces combat effectiveness. Rudel finally locates sufficient fuel for his mission, carefully calculating consumption rates that might permit target engagement and safe return. The mathematical precision required for fuel management contrasts sharply with earlier operational freedom when pilots could engage targets of opportunity without constant worry about reserve requirements. As Rudel prepares for takeoff, he observes empty aircraft revetments that once sheltered squadron mates now dead, captured or transferred to units facing different enemies on distant fronts. The Luftwaffe bleeds experienced pilots faster than training programs can replace them, creating expertise deficit that no amount of courage or determination can overcome. American P-51 Mustangs appear increasingly often over German territory, their presence indicating fundamental shift in air warfare balance. German fighters that once dominated European skies now struggle against superior numbers, better training, and inexhaustible American industrial capacity. Each mission becomes more dangerous as enemy capabilities improve while German resources diminish. Rudel's engine coughs to life, consuming precious fuel as he taxis toward runway. Behind him, most aircraft remain grounded due to fuel shortages, mechanical problems, or pilot unavailability. The mighty Luftwaffe that terrorized Europe now survives on fumes while American abundance floods hostile skies. February 20th, 1944. Big Week begins with thunder rolling across the skies above Leipzig, Germany, as nearly 1,000 American bombers darken winter horizons supported by over 800 fighter escorts. Captain Don Blakesley leads his P-51 Mustang squadron through dense flak fields that paint the sky black with explosive bursts, protecting Boeing B-17 flying fortresses targeting Messerschmitt aircraft factories below. Operation Argument represents the largest coordinated assault on German aviation industry ever attempted. American strategic planners identified aircraft, production facilities as critical vulnerabilities in German war machine. Destroying factories that build fighters eliminates future opposition more efficiently than shooting down individual aircraft that require replacement. Combined with attacks on pilot training facilities and fuel production, factory bombing threatens Luftwaffe operational capability at fundamental levels. Intelligence estimates suggest German aircraft production peaked during 1943 but remains vulnerable to concentrated assault. Major manufacturing centers at Leipzig, Regensburg, Schweinfurt, and Brunswick concentrate enough production capacity to justify massive bomber commitments despite expected heavy resistance. Success requires overwhelming force applied simultaneously to prevent German recovery through dispersed manufacturing. Blakesley's Mustangs engage. Luftwaffe interceptors climbing desperately to penetrate bomber formations. German pilots demonstrate remarkable courage attacking against impossible odds, but individual bravery cannot overcome systematic disadvantages that accumulate with each passing month. Messerschmitt Bf 109 and Focke-Wulf FW 190 fighters perform admirably within design limitations, but pilot inexperience and fuel shortages reduce combat effectiveness dramatically. American fighter tactics exploit German vulnerabilities through coordinated attacks that overwhelm individual defenders. Multiple Mustang squadrons converge on German formations, creating local numerical superiority that German pilots cannot match. Superior training, better communications, and unlimited fuel enable American pilots to press attacks until threats disappear or withdraw beyond effective range. Flak defenses around Leipzig fire continuously, creating steel curtains that bombers must penetrate to reach primary targets. Anti-aircraft artillery expends enormous quantities of ammunition in desperate attempts to disrupt bombing accuracy, but American formations maintain discipline despite losses that accumulate throughout approach and bomb run phases. Boeing, B-17 Flying Fortress. Hell's Angels shudders through flak bursts that pepper aluminum skin with shrapnel holes. Bombardier Lieutenant Robert Rosenthal peers through Norden bomb sight, calculating release point for explosive cargo that will demolish production facilities below. His aircraft represents one element in formation, delivering over 2,400 tons of bombs during single mission. German industrial workers scatter from factory buildings as air raid sirens wail across Leipzig. Production lines that manufactured fighter aircraft hours earlier now stand empty while high explosive and incendiary bombs transform manufacturing capability into smoking ruins. Each destroyed machine tool represents months of replacement time that German industry cannot afford. Luftwaffe losses during Big Week exceed 2,600 aircraft destroyed or damaged, including irreplaceable pilots whose experience cannot be quickly replaced. Training programs already reduced by fuel shortages face additional pressure as instructor casualties mount. German Air Force that dominated European skies through superior tactics and pilot skill now struggles against industrial capacity that dwarfs their production capability. American losses, while significant, remain sustainable due to massive production rates and comprehensive training programs that graduate replacement crews continuously. Each lost bomber can be replaced within weeks, while aircrew training produces pilots faster than combat operations consume them. Mathematical advantage shifts decisively toward Allied forces as German reserves diminish. Factory damage assessment photographs reveal devastation that exceeds optimistic projections. Machine shops lie buried under collapsed roofs. Assembly lines twist into unusable scrap metal. Power plants and transportation networks suffer collateral damage that compounds primary target destruction. German production schedules face months or years of disruption. Smoke pillars rise over Leipzig as Blakesley's squadron escorts bombers toward home bases in England. Below, German industrial capacity burns while American factories work continuously to replace aircraft and equipment expended during Big Week operations. The mathematical equation of industrial warfare tilts inexorably toward Allied victory as democratic production overwhelms totalitarian capability. Augsburg, Germany. February 25, 1944. Maria Weber picks carefully through twisted steel beams and concrete rubble that yesterday housed precision machine tools building. Messerschmitt fighters for the Luftwaffe. Smoke still rises from smoldering wreckage, while emergency crews search for survivors trapped beneath collapsed factory sections. The devastation extends far beyond primary target areas, encompassing residential neighborhoods where aircraft workers lived with their families. Weber's husband. Friedrich operated boring machines that created engine cylinder blocks for Messerschmitt Bf 109 fighters. His specialized skills, developed over 15 years of peacetime experience, cannot be quickly replaced even if factory infrastructure survived Allied bombing. The combination of destroyed equipment and dispersed workforce creates production bottlenecks that will require months to resolve. Assuming raw materials and replacement machinery remain available, American strategic bombing doctrine emphasizes industrial targeting rather than civilian terror. But modern warfare blurs distinctions between military and civilian infrastructure. Aircraft factories require electrical power, transportation networks, and housing for workers who live nearby manufacturing facilities. Destroying primary targets inevitably Damages supporting systems that enable industrial production. German propaganda attempts to maintain civilian morale through claims that bombing attacks strengthen resolve rather than weaken resistance. However, reality contradicts official optimism as production statistics reveal accumulating damage that cannot be hidden from industrial managers responsible for meeting military quotas. Each destroyed factory represents reduced capability that affects frontline operations within weeks. Throughout 1944, American aircraft production reaches 96,000 military planes, while German output struggles toward 39,000 despite controlling much of European industrial capacity. The disparity grows monthly as Allied bombing reduces German capability, while American factories operate beyond theoretical capacity through improved efficiency and extended working hours. Weber surveys destruction that extends beyond immediate factory areas into residential sections where aircraft workers lived. Apartment buildings collapse under blast pressure that shattered windows throughout Augsburg. Schools, hospitals, and churches suffer damage that disrupts civilian life even when bombing targets military objectives. Exclusively emergency services struggle with casualties that overwhelm medical facilities already strained by military requirements. Ambulances transport injured civilians to hospitals lacking adequate supplies for treating blast wounds and burns. Medical personnel work without rest, while utility crews attempt restoring essential services to damaged neighborhoods. German Civil Defense Organization, developed through years of preparation, demonstrates efficiency under impossible circumstances. Air raid wardens guide civilians to shelters during attack warnings. Fire brigades battle blazes that threaten to spread beyond primary target areas. Rescue teams search collapsed buildings for survivors, while explosive ordnance disposal experts remove unexploded bombs that threaten future safety. Despite civilian courage and official determination, cumulative damage gradually erodes German industrial capacity beyond recovery. Each factory destroyed requires months to rebuild, assuming materials and skilled workers remain available. Dispersed production, attempted as protection against bombing, reduces efficiency while increasing transportation requirements that strain limited fuel supplies. Transportation networks suffer particularly severe damage as Allied bombers target railroad yards, bridges, and canal systems that support industrial operations. Raw materials accumulated for aircraft production become inaccessible when transportation systems fail. Completed aircraft cannot reach operational squadrons when railroad lines suffer repeated attack. Weber's neighborhood exemplifies broader German civilian experience as total war reaches every aspect of daily life. Food rationing intensifies as agricultural areas face labor shortages. Consumer goods disappear from stores as factories convert to military production. Educational systems collapse as teachers join military service or defense work. Cultural activities cease as resources concentrate on survival needs. International Red Cross observers document civilian suffering while maintaining neutrality required for humanitarian operations. Medical supplies provided through neutral countries alleviate some hardship but cannot compensate for systematic destruction of civilian infrastructure. German civilians endure privations that exceed previous wartime experience as industrial warfare targets entire societies rather than just military forces. For every German aircraft completed during 1944, American factories produced 3 equivalent machines while maintaining higher quality standards and superior pilot training programs. The mathematical imbalance guarantees eventual Allied victory, while German civilians pay prices for leadership decisions beyond their control. Weber walks away from factory ruins, carrying few salvaged possessions toward uncertain future in devastated city. Night shift at Ford's Willow Run plant, December 1944. Under harsh fluorescent lighting that banishes darkness from the factory floor, Rosie Will Monroe guides her rivet gun with mechanical precision that speaks of thousands of repetitions perfected through months of relentless practice. The metallic percussion echoes like artillery fire, throughout cavernous spaces where aluminum sheets transform into flying weapons, faster than German planners consider physically possible. Monroe's production line operates 24 hours daily, generating one completed B-24 Liberator bomber every 55 minutes at peak efficiency. Night workers maintain pace established during daylight hours, their concentrated attention sustained by knowledge that every aircraft carries 10 American airmen into combat over hostile territory. Quality control inspectors examine each rivet, weld, and assembly joint with exacting standards that ensure structural integrity under combat stress. American industrial capacity defies European understanding of manufacturing limitations. Willow Run employs over 42,000 workers producing bombers with assembly line techniques adapted from automobile manufacturing. Component suppliers throughout North America coordinate delivery schedules that maintain steady material flow despite transportation challenges created by wartime conditions. Beyond bomber production, North American aviation facilities manufacture P-51 Mustang fighters at rates exceeding 400 aircraft monthly. Combined output from Inglewood, California, and Dallas, Texas, plants floods European skies with long-range escorts that protect bomber formations throughout entire mission profiles. Each Mustang embodies sophisticated engineering married to mass production capability that German industry cannot match. Strategic material abundance enables American production rates that seem impossible to resource-starved opponents. Aluminum supplies flow from domestic sources protected by geography impossible for enemy forces to threaten. High-octane aviation gasoline flows from refineries operating beyond bombing range, while German synthetic fuel production collapses under Allied attack. Skilled workers receive adequate nutrition and compensation that maintains productivity levels throughout extended production campaigns. Monroe pauses her rivet gun as another bomber section moves toward final assembly areas. The aluminum skin gleams under factory lighting, reflecting countless hours of American labor transformed into instruments capable of carrying 24,000 pounds of explosive cargo across hostile skies to German industrial targets. Her work contributes directly to strategic bombing, campaigns that systematically destroy enemy production capability. Contrast with German conditions become stark as intelligence reports describe fuel shortages that ground Luftwaffe squadrons for weeks at a time. German aircraft factories operate with skeleton crews using improvised materials, while Allied bombing reduces capability monthly. Training programs collapse as fuel rationing prevents adequate flight instruction for replacement pilots who die during first operational missions. American advantage extends beyond raw production numbers into comprehensive support systems that sustain military operations across global theaters. Spare parts flow continuously from manufacturing sources to maintenance depots scattered throughout Allied territory. Replacement crews graduate from training programs faster than combat operations consume them. Logistical networks deliver supplies with efficiency that enables sustained operations regardless of distance from home bases. By late 1944, German fuel production falls 90% below 1943 levels due to strategic bombing campaigns that target synthetic petroleum facilities and transportation networks. Romanian oil fields at Ploiești face continuous attack by American heavy bombers, protected by Mustang escorts operating at maximum range. Each successful mission reduces German capability while American production accelerates. Monroe's factory represents democracy's industrial heart beating with rhythm that will carry freedom across oceanic barriers to fascism's doorstep. Night shift workers understand their rivets hold. Together more than aluminum sheets, they bind American determination into weapons that democracy wields against totalitarian opposition threatening global civilization. Assembly lines continue, operating while German factories stand cold and empty. Raw materials stockpiled for future production become inaccessible when transportation systems fail under bombing pressure. Skilled workers disperse from destroyed facilities, carrying irreplaceable expertise beyond recovery within timeframes relevant to military operations. While Germany counts every liter of fuel and rations aluminum sheeting, American production floods hostile skies with aircraft exceeding enemy comprehension of industrial possibility. The machine that does not stop proves democracy's capacity for unlimited production when civilization itself faces existential threat. Luftwaffe Training School, Brandenburg, Germany. March 1945. Empty aircraft hangars stand like cathedral ruins beneath gray skies, their concrete floors swept clean of everything except memories of pilots who once learned flying skills in comprehensive programs that produced Europe's finest aviators. Hans-Joachim Marseille's flight manual lies abandoned on a dusty desk, its pages describing aerobatic techniques and gunnery procedures that new recruits will never have time to master. The collapse encompasses more than individual training facilities. Systematic destruction of German pilot education reflects broader disintegration of military capability that once dominated European skies through superior tactics and experienced leadership. Flight instructors who survived combat operations now fly desperate missions against overwhelming Allied opposition, leaving training programs without qualified personnel. Fuel shortages prevent adequate flight instruction even when aircraft and instructors remain available. Student pilots receive fewer than 20 hours of actual flying time before operational assignment, compared to over 200 hours provided during 1940 when Luftwaffe resources seemed unlimited. Mathematical impossibility of combat survival with inadequate preparation guarantees pilot losses, exceeding replacement rates maintenance. Hangars that once sheltered training aircraft now stand empty as parts. Shortages make repairs impossible. Engines run beyond overhaul limits, airframes develop cracks, and ground crews improvise with limited tools. Failures rise as equipment exceeds safe life. The German aviation industry that produced nearly 40,000 aircraft in 1944 cannot sustain training or combat needs. Student accidents consume planes faster than factories produce them, while combat losses drain operational strength. Training commands compete with frontline units for scarce machines. By 1943, the Luftwaffe peaks, but losses soon exceed production. By 1945, fewer than 300 fighters remain, while Allies deploy over 11,000 aircraft for invasion. Winter weather increases fuel use and accidents. Radios fail for lack of parts, and navigation aids prove unreliable. Students learn on defective equipment, manuals go obsolete, and classrooms make do with chalk and rationed paper. Food shortages reduce concentration, and medical care vanishes as doctors transfer to the front. Training programs shorten, producing pilots with gaps in knowledge. Obsolete trainers are armed and sent to combat, while students fly missions before completing instruction. Brandenburg facility mirrors this decline. Empty runways, once filled with aircraft, now stand silent. The death of an air force begins when training fails to produce replacements capable of meeting enemy opposition. June 6, 1944. Dawn breaks as the greatest armada in history heads toward Normandy. Over 5,000 ships carry 156,000 troops, supported by 11,590 Allied aircraft. Fighters sweep ahead, bombers strike defenses, transports drop paratroopers, and reconnaissance planes report troop movements. Luftwaffe response is negligible, fewer than 300 sorties. Strategic bombing, fuel shortages, and attrition have reduced the once mighty force to impotence. Captain Don Blakesley's P-51 squadron sees no German aircraft during patrol. Allied fighter bombers devastate strongpoints, tanks advance undercover, and artillery is destroyed from the air. Strategic bombers cripple bridges, rail yards, and highways, isolating defenders. Fuel shortages keep most German aircraft grounded. Allied air supremacy ensures rapid medical evacuation and free movement of troops and supplies. Within hours, the beaches are secure. Open skies guarantee the invasion's success. May 8, 1945. Victory in Europe Day. Rows of worn P-51 Mustangs rest silent at Debden, England, their missions complete. Captain Blakesley reflects on 2 years of combat, touching battle scars on the aircraft. Mustangs destroyed 4,150 enemy planes in over 213,000 sorties, achieving kill ratios approaching 10-1. German industry could never match Allied numbers or training. Hermann Göring, once confident no enemy bomber would reach Germany, now faces the ruins of his boasts. Hans-Ulrich Rudel, legendary Stuka pilot, admits courage could not offset industrial inferiority. In America, factories like Willow Run that built bombers now turn to civilian cars. Rosie the Riveter's wartime work transforms into peacetime prosperity. Strategic analysis confirms air superiority as decisive. Bombing crippled fuel. Transport and factories reducing Luftwaffe capability below survival thresholds. The U.S. built 96,000 aircraft in 1944 while maintaining civilian production, proving democratic industry's unmatched capacity. Engineering advances like the Mustang emphasized reliability, simplicity, and mass production over theoretical perfection. Delivering performance superior to German designs. American training programs produced more crews than combat consumed, sustaining operations where German shortages collapsed instruction. Logistics networks spanned oceans, delivering spare parts, fuel, and aircraft without interruption. Abundant resources, not just tactics, guaranteed Allied success. Air supremacy enabled operations across all theaters, protected civilians from air terror, and gave ground forces freedom of movement. Its legacy extended beyond victory. It became the model for modern defense and Cold War doctrine. Wartime industrial capacity laid the foundation for post-war prosperity and U.S. leadership. The Mustang symbolized more than escort duty. It proved democracy could outproduce dictatorship, combining free enterprise and collective effort to defend liberty. If you enjoyed the story at hand, pick this next story that you will enjoy. Please don't miss this one. Click here to watch it